In this video, we're going to talk about the rules for naming molecular compounds. In a previous video, we talked about our four main types of compounds. They can be ionic or molecular, and a subset of ionic are acids and bases. Now notice that molecular is different than the other three types of compounds. Ionic compounds, acid and bases are all made of a positive and negative ions, whereas molecular compounds are not made of ions. And for this reason, when we name molecular compounds, we are going to state the number of atoms in the name. In all the other types of compounds, we don't state number in the name. And that's because we can predict the formula. This slide says the same thing. Unlike the other types of compounds, we cannot predict the formula of a molecular compound. So if we have a compound between N and O, it might be the first, the second, or the third. We don't know. We don't know which one it is because more than one compound can exist between the same types of atoms. For ionic compounds, acids, and bases, that simply isn't true because there's only one possible compound that can exist, because calcium only forms a +2 ion. Fluoride only forms a -1 ion. This is the only formula that's electrically neutral. So there's only one possible compound that can exist between Ca and F, or Al and S, or H and Cl, or Na and OH. So because of that, we won't state the number of ions in the name when we name these compounds, but molecular compounds are not made of ions, so we do have to state the number of atoms in the name. And then this slide says the same thing. When we name these compounds, we're going to state the number of atoms in the name. First, we're going to name the first nonmetal atom. Remember, molecular compounds are made of nonmetals only. And then the second word is going to be the nonmetal stem, and then we'll replace that last suffix with IDE. If we have more than one atom, we're going to use Greek prefixes. And here's our order that we put our nonmetal atoms. This is our table of our Greek prefixes. You should memorize this. Let's name this molecular compound. So what we're going to do is write the name of the first nonmetal, which is phosphorus. For the second nonmetal, we are going to write its name, then get rid of the suffix, so we have the nonmetal stem. And then what we're going to do is add the suffix IDE. So we get rid of the last suffix and replace it with IDE. And then we're going to use these Greek prefixes to state how many. So to say that there's 4 phosphoruses, we use the prefix tetra, so tetraphosphorus. Second word, we want to say 3 sulfide ions, so tri and then sulfide. Let's name these compounds. And whenever we name a compound, the first thing we want to do is pull out the periodic table and classify the compound as molecular, ionic, acid, or base. There's going to be different rules for the different types of compounds. So this section is naming molecular compounds, but really let's just verify that these are molecular. So SF6, S and F are in the nonmetal portion. PCl5, P, and Cl are nonmetals, and S and O are nonmetals. So I just want to emphasize step 1 is pull out that periodic table and verify the type of compound. So with molecular compounds, we state the number of atoms in the name. That won't be true with anything else, any other class of compounds. Now that we've verified that this is a molecular compound, we'll name it. So S is sulfur, F is fluorine. We get rid of the suffix and replace it with IDE. There's only one sulfur. We don't have to say that there's one. We just write sulfur. And then we have to say there's 6 fluorines. So we know the Greek prefix for 6 is hexa, so sulfur hexafluoride. PCl5, phosphorus, and then Cl is chlorine. Get rid of that last suffix and turn it into IDE. And then we have to say there's 5 of them, and 5 is penta. So phosphorus pentachloride. Notice the last two are between sulfur and oxygen. With molecular compounds, we can have more than one compound between the same nonmetals. S is sulfur, oxygen is O, then get rid of the last portion of the word and keep just the nonmetal stem, and then that becomes oxide. So sulfur trioxide, where tri is 3, and sulfur dioxide for 2 oxygen atoms. Here's another example you can work out on your own. And there's one last rule, and this applies only to nonmetals that begin with a vowel, oxygen and iodine, and only if the Greek prefix ends in A, which is the ones I've underlined, or O. And it'd probably be easier to say it doesn't apply for di or tri. So what this rule is trying to do is not have two vowels, the A or the O, next to each other, but that won't apply if it's di or tri. So if the prefix ends in A or O and it's before a nonmetal that begins with a vowel, we drop the A. So look at this, N2O4, dinitrogen, we state that, and then notice that this doesn't say tetraoxide, it says tetroxide. So we've dropped the A so that we don't have two vowels next to one another. For N2O5, we don't say pentaoxide, we say pentaoxide. However, if the Greek prefix was di or tri, we keep that I and we have two vowels next to each other, nitrogen dioxide. And here's some more examples you can look at on your own.